All right, now we're going to do a DT graph. There's a whole bunch of questions, so we'll start off with the fact that it's a DT graph, so we're going to need to add that in to DT graph. Since you have positive values and negative values, it means it's a displacement time graph. You're in the positive here, you're in the negative there, and then you're back up into the positive. So for part A, it says how far from its starting point did it move in the first 13 seconds. So if this is a car that's driving, we just want to know how far. Far doesn't really care about direction, just like if it's a car, it's just your odometer. So what we'll say then is that we start from 0 and we're going to end up at 13, which gets us to there. And all you want to do is look at your displacement axis or your distance axis and count how much you've actually gone. So let's see here. From here to here, that's 30. And then all the way back to 13, that's going to be, actually no, that's not 30, that's 40. Okay, and then you're going to go from 40 all the way down to 60, which is another 100. So in total, your odometer would read 140. Okay, so I guess I'll write that right there. 140 meters. Okay, so that's your distance, or how far. What was it doing between 13 and 16 seconds? So we go to 13 seconds, starts there, 16 seconds, it's there. Well, horizontal line on a DT graph, that means that it was doing nothing, it was stopped. Okay, I guess I'll write that there, stopped. Total displacement for the 20-second journey. So you start here, you end there. You got a lot of different things that you can do. You can call this positive 40. You can call this negative 100 because you're going downward. You can call that 0, and then you can look back at this and call it another positive, whatever that is. From 60 to 30 is positive 90. And then what you would do is you would go positive 40. You see that? Positive 40 minus 100 plus 0 plus 90, which would be 130. So that'd be positive 30. So right here, it would be positive 30. That's your total displacement. Another way you could have done that, a little bit of a trick, is you go from the start of your journey, which is 0, to the end of your journey, which is that line there, which is positive 30 above where you started. So that would be another way of figuring out your positive 30 meters. And finally, your total distance for the 20 seconds. You don't care about positive or negative, so that would be positive 40, or it would just be 40 plus 100 plus 0 plus 90. So that would end up being, let's see, 190, 230. So 230 meters. Okay. The part E, finding the average velocity for each of the following segments. I'm going to use this right here, a new DT graph, something that's going to have just a little bit more space so that I can make it bigger. Let's there, go to that. Now, for the first one, it says find the average velocity for segment 0 to 4. So we want to figure out how fast you're going from here to 4 seconds. I don't know if you remember that on a DT graph, your average velocity is d2 minus d1 over t2 minus t1. So for this one, you're going to end up finding an average velocity, and it's going to be d2, which is 40, minus d1, which is 0, over t2, which is 4, minus t1, which is 0. So for this first one, your average velocity is going to be 40 over 4, which is going to be positive 10 meters per second. Okay, so that's your first average velocity for 0 to 4. The next one, part B, or whatever you call it, 2, would like to know from 7 to 13. Now I did this on purpose. 7, you can see, doesn't map out nicely. It's kind of in an awkward position. But when you have a straight line on any graph, on a DT graph, if you have a straight line, you can pick any 2 endpoints you want. So I'm going to pick this as one endpoint, that is my other endpoint, and I'm going to find the average velocity by going d2 minus d1 over t2 minus t1. This is d2, so that's minus 60. Minus d1, which is 40. T2, which is 13, and here's where the common mistake is. T1 is not 7, it's actually your whole entire line that you've chosen. So that's going to be 4. So your average velocity in this case is going to be minus 100 divided by, so what's that? 9. So your average velocity of minus 100 over 9 is going to be minus 11.1 meters per second. So that is for 7 to 13. And the last one would like to know your average velocity for the entire journey, starting here, ending there. So what you could do is you could think about connecting that line, and your average velocity is going to be d2 minus d1. So let's get some space here. d2 is 30 minus d1 is 0. T2 is 20 minus T1 is 0. So your average velocity in this case is going to be 3 over 2, which is going to be 1.5 meters per second, and that'd be positive. There you go. There's 3 average velocities on a DT graph. Now, just verify, that's positive velocity, that's negative velocity, that's no velocity. You would actually call that 0 meters per second. And that's again positive velocity. And I found the average velocity for the entire journey by making a new line. Okay, there you go.